Now, the other thing I used was I called something damping. So what is damping? What will happen to this system, mass spring system, in a real life scenario? If you let it go, it will come to rest. So in physics, we call it losing mechanical energy as a result or friction. So the fact that when you let go of things on planet Earth, they come automatically to rest is in physics called losing mechanical energy. And as long as we are on Earth, we cannot eliminate friction. No matter how good we make our system, it will eventually come to rest because of two things. There is friction that naturally exists when two things rub against one another. And then there is also drag. The fact that you're always flowing through a medium. Air is a medium, water is a medium, whatever you're going through, there's always going to be a force called drag. And you cannot ignore either of them. So in this system, it will eventually come to rest. So the sine curve, do you remember the sine curve that we've been drawing? It was always this. This actually corresponds to this kind of a sine curve, where the amplitude of this decreases as we go forward. Until it comes to rest. When it comes to rest, it just becomes that. That is called a damped harmonic oscillator. So there are two more terms I need you to pay attention to. One is called the envelope, which is shown here by the pink dotted line. It's the curve that follows the damping motion. It's called an envelope and sometimes also called a decay curve. By definition, it is the change in amplitude with respect to. So physics people like to not write with respect to. So you may see WRT written in a lot of places. That is read as with respect to. With respect to. Another definition is a vibrating system whose amplitude decreases is said to be damped. And the rate at which this damping happens is called a damping constant. So you could have a larger damping constant or you could have a smaller damping constant. So you could have a curve that looks like this, where it damps very slowly, or you could have a curve like this. This is a heavily damped, and this is a lightly damped system. So imagine the top one is like a simple pendulum going through air, whereas the bottom one is a simple pendulum going through water, right? Damps quickly. Okay. So when you're talking about damped harmonic oscillators, our energy conservation, which was given by, so energy conservation, which was given by delta E equals 0, that means energy cannot be created or destroyed, no longer is valid. In this case, the law of conservation of energy will be written as this. So that means that delta E, in case of where friction is present, will be given by work done against overcoming friction. And we define the work done as force times displacement. How much force happened and how much distance did that force travel? So all you have to do is to remember energy conservation under conserved conditions, which basically implies no friction, or under damped conditions, which implies friction is present. So whenever you have a situation like this, remember that you will have to take into account that friction is present. So the three kinds of damped oscillators include underdamped, overdamped, and critically damped. So think about these three things as this. So underdamped will be in air. It will oscillate for a long time before coming to rest. Overdamped would be kind of like when you have it in water. It will come quickly down, but it will still oscillate maybe once or twice. Critically damped is what happens when you put your mass in a honey, for example. Is honey really viscous? Is really thick? So what will happen if you try to move anything in honey? It won't go anywhere. That's called critically damped. The main types of damping include external damping, or they could include internal damping. External damping includes the energy that is there, like for example, the frictional force we talked about and the drag we talked about. But there is also additionally something called internally damped. Internal damping is very, very difficult to overcome once something has been built. They could be due to the molecules themselves, the thing you made your car out of, the molecules in the system, or they could be made because something is being stretched with about something else.